Well, hello guys. Starting the stream now. Okay, so welcome to this fresh new episode of Computer Geeks. And I'm your host Onkon. Often it will be a bit late today. Sorry about that, but still, yes. So here we are, joining today. See ya. So here we start in like 3 minutes. Yes, guys. Sorry for the inconvenience. So yeah, I'm back again. So what would be today's topic? Check out. So today we're gonna discuss about how the CPU works. Yes, that is the topic today would be how the CPU works perfectly. So this will be a huge subject. So on the mega launch day today we're gonna talk about some difficult subjects, but it will be fun too. After we'll be joining the stream a bit late, as I've already said, because there are some problems with him. But still, it's okay, no problem. Okay, let's first put some great music. Oh, not now. Okay. So yeah, let's start. CPU. What do we mean by that? CPU can be is the abbreviated form of the thing called central processing unit. Now CPU can be also compared to the brain of a computer. So yeah, as our subject today, what would be the CPU? I have a copy filled with stupid things. So don't worry, I'll be trying my best in paint. Sorry, but the drawing could be a bit glitchy because I don't actually have a drawing table or a drawing pad. So yeah, I'll be using my mouse. Still, let's see how much we can. Okay, so central processing unit. Okay, yeah, central processing unit. So there are actually three things that we have to learn about first. First ones are called registers. Yes, there are registers. So yeah, let's list them down on notepad so it will be really easy for us to explain. Let's change the font a bit. So yeah, we'll be teaching about how the CPU works. So yeah, we would need some great fonts. Just a bigger size would do it. Okay, so the first thing we're gonna know is about the registers. Well, what are these registers? ALU and RAM and all those things that we're gonna learn, but later. First, imagine a CPU. A CPU is inside your motherboard's casing. The motherboard is the basic board in which the CPU is embedded in. So yeah, that's the CPU basically in there, and it's a kind of chip. It's the brain of your computer, as we already know. So if you open it up, you would indeed expect to see a lot of microchip boards with a lot of circuit boards, and you know what I mean, a lot of things. So yes, sorry for that. But the thing is, we have to check it out. What's in that to actually learn about it first. So the first things you would open up and see are called the registers. The second thing you would see inside a CPU is called an ALU, and it is the abbreviated form of arithmetic. Sorry, arithmetic logic unit. And the third thing we'll be discussing about is RAM and your hard disk drive. Well, I know these are not part of the CPU, but they have some interaction with the CPU in one term or another. So yeah, we'll be discussing about them too. So yeah, these things we're gonna learn about: registers, ALU, RAM. So let's give you a clear picture of what the CPU looks like inside the CPU. Let's check out some pictures to make it clearer. I know there are some couple of videos, but yeah, I'll be teaching them perfectly. Now, this is what would actually inside a CPU would look like, but this is a really not a great, not a great image. This could be an explanation of what CPU actually looks like. Never mind the AMD thing, but yeah, this is the kind of thing. Wait for the picture to be cleared up. So yeah, we see here the cores: core 1, core 2, core 3, core 4. So today we won't be discussing about cores and all those, but it's just a normal picture of what a CPU actually looks like. Look at this, small parts. Yes, but they all have a single function, and we're gonna learn about their functions today. Okay, so let's get in. First of all, we have to know that inside a CPU, there is a wire that turns on and off steadily to keep everything in sync. In sync means to make this work and to make that work together and to having a perfect balance of everything. And that wire is called the clock. Now, you can hear people bragging about their clock speed, like, hey bro, my clock speed is 3 gigahertz. Hey, my clock speed is actually 2 gigahertz, so mine would not be better than yours. But yeah, not, this is just an example. But yeah, the clock speed. Well, so what is this gigahertz thing? So, in here, this is giga. This is actually hertz. HERTZ, hertz. So here, the giga. Okay, so you might expect that 1000 megahertz is equal to 1 um, gigahertz, most possibly. Okay, this could happen, but the thing is that we don't expect it to be like that. So in this case, giga means a billion, and hertz, if you have learned physics already, then hertz is per second. So that means a normal CPU can process a billion data per second. Now that's really amazing what you did say. Yep, that's too amazing. So first of all, let's start going from here and then to the front. So first of all, we will be discussing about RAM and hard disk drive. So here, as we have already mentioned, we learned about RAM as its interaction with the CPU. So what is actually RAM? RAM is random access memory in your computer, but actually what does RAM do? Well, RAM contains a list of addresses. Well, think about it like this. There are two houses. For example, yeah, let's just say there are two houses. I'd give the name 1, 2. Sorry, my drawing is horrible in this. Okay, 1 and 2, two houses. So each one drinks a different beverage. This drinks milk, and this drinks water. Milk and water. This is the house address, 1 or 2, and this is the data they contain. Just take it as an example, okay? Milk or water. Sorry, the drawing is really horrible. Okay, just really horrible. So milk and water. This is house number 1. Sorry, house number 1 drinks milk, and the house number 2 drinks water. So let's just to keep it simple, name 1 as the address and 2 as the address 2, and this is the data. Well, in case of computers, address comes in formats just like this: FFF0. Well, yeah, you must have seen the RGB colors, red, green, blue colors as these two, but no, those are not the addresses. So the address in a computer looks like this, that is stored in your RAM. And what the address holds is in a kind of obstructed number, which is called binary codes. Well, binary codes, as we have already know, you might know actually, but I won't be going into detail about how to know what binary codes do and how do they work out, like how is A this and how is B that. Yeah, so for this today's video, our main function is to learn about the CPU, so we'll be just doing that to keep us according to the subject, not doing anything else, okay, not thinking about something else. So for example, this address FFF0 has a binary code of 101101. I'm not sure if it's a binary code or not. Just take this as an example, okay? Just a rough example. Simple. So RAM contains this address, and this address says my data is this, just like the house we just explained. So it's simple like that. So how does RAM interact with CPU, and what is its function? Well, there are two functions of RAM. The first function is that it stores data, and the second function is that it stores more of the values from a register, or CPU can use them to store addresses. More amount of addresses means that the CPU can work faster, and that's why they say if you have 4 GB RAM, your PC would be really fast because your CPU can handle more. The original clock speed is really high, but the thing is that only the clock speed can do enough what you're doing. For example, the modern computer that you were using to watch this video currently on Twitch, on my channel, Computer Geeks. The thing is that this is using a very lot of your memory, believe me. 1 billion of data of this video is being processed into audio and visual picture for your monitor from that CPU. Yes, a billion per second, gigahertz. And if it's 2 gigahertz, then my friend, you have an awesome CPU, by the way. And 3 gigahertz, perfect. I won't be judging any computers currently because I'm not in this. Sorry guys, not login, but it's logic. Sorry about that. Okay. Yeah, so it's FFF0110. Okay, so after that we'll be learning about how the CPU requests data. Well, a CPU. Okay, so there's a reason between why RAM is called random access memory, because a CPU requests data, and there are two ways a CPU can request data: in an orderly manner, in an orderly manner, or in a random manner. So in an orderly manner, when the CPU is normal, it can actually bring out data from the RAM in an orderly manner, so there are no problems. But if the CPU wants, then it can also bring the data randomly if it needs to. That's the thing. If it needs to, that's an so we could say it's an exception. But what we see is this exception occurs more than the orderly data, and that's why the RAM was named random access memory, RAM. Simple as that. So now a bit of a diagram time, okay? My drawing is horrible, I know that. Okay, so think you have your CPU over here. This is your CPU, and you have your RAM. Okay, sorry about that. Just a bit of labeled out. Sorry about that. Okay, so just think you have a RAM over here, the RAM memory stick or the RAM. So what you could RAM look like? Well, if you could search, okay, not this, but if you could search RAM in a computer, I could show you some images because many people don't know what a RAM is. So yeah, this is a very example of RAM. These are RAMs. Here, these are all RAMs. See, you might see them beside the CPU. Well, I don't know what kind of RAMs are these. Oh, that's a wait. Is that a Corsair? No, I don't know what kind of RAMs are they. Yeah, these are normal RAMs that you find in your CPU if you open your casing up. But be advised, okay? I'm not saying you to actually open up your CPU, but don't do that unless there are some kind of problems. So yeah, this is the kind of RAM you would have normally. Very normally, this kind of RAM you would have. So yeah, these are the RAMs. If you open your casing, you'll get this kind of RAMs. Sorry guys for the background noise. Someone is really shouting out, and I'm really sorry about that. I just wait. I have to control the noise pollution. Okay, sorry. Excuse me for that. Okay, so yeah, your computer and RAM. So there are usually two sets of wires that goes. Okay, and there are some other sorts of wires between CPU and RAM from these sides. Okay, don't worry about them. But we need to know about these two wires: a set wire and an enable wire. I know there are really strange names, but the first wire is a set wire and the second one is the enable wire. So when the CPU requests a data, it sends the RAM a request. So the CPU sends the RAM a request. So it says, "Hey RAM, can you give me this data?" And the RAM says, "Okay, okay, I will give it to you." So then the CPU turns on the enable wire, and the RAM sends the data, including the address, to the CPU, and that the CPU does a lot of things with it. But the main thing is the enable wire that actually goes with the RAM and does all these things. See, the RAM to the CPU. That's the basic thing. And sometimes we need to save data to RAM too. So to do that, CPU has to know which address it will save its data to. So there's a set wire. Here we go, the set wire, and so the CPU just outputs the address and the data to the RAM, turns on the set wire of the RAM, and so the RAM saves it. So basically, guys, you have to know about two wires in exception, and that is the main thing. The first wire that you would want to know about is the set wire, which is when this turns on, everything is saved. And there is an enable wire, which which is when it is turned on, it will actually output some kind of data to some other components. So the two wires are the set wire and the enable wire. you have to always remember this. Okay, so we have to actually keep up with these because we will use these terms a very lot, believe me, a very lot. Okay, so some more explanations. So this is the basic explanation of that. So yeah, as you already know what instruction that RAM contains. So yeah, RAM contains instructions. Well, have you ever wondered how does your CPU know what to do? Well, it gets instructions. For example, you give the CPU an instruction. For example, when I try to write something in my notepad, for example, anything like hi, if I write this, then I'm inputting it with my keyboards. Is going to the CPU, and the CPU processes it and says there's a lot of complicated process which you will know. You will know it, okay? But still, for now on, we just say this that from our keyboard it goes to